morning, student. Today we will discuss conductance of electrolytic solution. Lecture number 6, chapter number 3, electrochemistry. So before discussing the conductance of electrolytic solution, we should know the basic terms related to conductance. So first we will discuss basic terms. Later on we will discuss conductance of electrolytic solution. First basic term is resistance. Resistance of substance. Resistance of substance symbol is R. Remember. Now resistance. By which instrument the resistance can be measured? So we know it can be measured by Wheatstone bridge. Resistance is measured in which unit? So it is measured in a unit of ohm, and this having a symbol like this. We know in a SI unit, ohm can be represented as in a SI unit. Ohm can be, that is 1 ohm equal to kg meter square second cube and ampere square. Now we know very well for any substance R is directly proportional to length and R is inversely proportional to the area of substance. That means that R proportional to L by A, and therefore R equal to rho L by A. Remember, this is a basic useful formula. Now what is rho? This symbol is known as rho, proportionality constant. What is rho? The second basic term is rho, that means which is known as resistivity. Resistivity, otherwise it is also called specific resistance. Specific resistance. This symbol is known as rho. Now rho equal to R A divided by L. That means the unit of rho. Unit of R is ohm. Now suppose area is taken in meter square and length in meter, then unit is ohm meter. This will be the SI unit. SI unit. Suppose area is taken in centimeter square and length is taken in centimeter, then a unit will be ohm into centimeter. Now what is the definition of resistivity? So resistivity is actually one type of resistance is there, because when area is taken as 1 unit and length is also 1 unit, that means A equal to 1 unit. That means 1 centimeter square or meter square, and the length is also equal to 1. That means 1 centimeter, otherwise 1 meter. Then the resistance, which is the measure of the substance, which is equal to the resistivity. At that time, rho becomes equal to R. That means the resistivity is one type of resistance when the area is taken as 1 and length is taken as 1. Now third basic term is conductance. Conductance having symbol G. So obviously resistance and conductance name suggests inversely proportional. That means the inverse of resistance. Inverse of resistance is called conductance. That means G equal to 1 upon R. Remember, once the resistance is known, then inverse is known as conductance. Otherwise, from this we can also write R equal to rho L by U. That means 1 upon R equal to 1 upon rho. Then this will be inverse. That means A by L. So we can also write that this will be equal to 1 upon rho into A by L. Also we can write this will be same. So this value gives the formula. This is the formula of conductors. Now what will be the unit of conductors? This R having unit so unit of conductance is unit. This will be ohm inverse. Ohm inverse, otherwise we can also say it will be mho. Ohm inverse, that means symbol will be like this. This will be the symbol of mho. Ohm inverse, that means we can also write like this. Now, what is the SI unit? This ohm inverse is also written as Siemens. That means SI unit will be Siemens. Symbol is S. That means 1 ohm inverse equal to 1 Siemens. Now, fourth importance term is here resistivity. So inverse of resistivity. Inverse of resistivity, that means conductivity. Conductivity symbol is kappa. Otherwise, it is also known as specific conductance. Conductivity, otherwise specific conductance, but IUPAC suggests instead of specific conductance, conductivity word is used. Here also instead of specific resistance, this resistivity word is used. So we will use resistivity and conductivity. Now conductivity means the inverse of resistivity. The inverse of resistivity. Is called conductivity. That is symbol is kappa. That means this kappa, that means conductivity equal to 1 upon rho. 1 upon rho. Now again 1 upon rho, that means by this 1 upon rho, that means this will be equal to 1 upon R. Again inverse, that means L by A. So this will be same. Again this is equal to 1 upon R. 1 upon R is conductance, that means conductance into what is the unit of conductivity? The resistivity having a unit ohm meter. So here also inverse, that means ohm inverse of meter inverse there. Again, suppose ohm centimeter unit is the resistivity, then it will be ohm inverse centimeter inverse. Now we know very well SI unit. Ohm inverse is similar to Siemens. That means SI unit. Siemens meter inverse. So this will be the SI unit. SI unit of conductivity. SI unit of conductivity. Now what is the definition of conductivity? Actually, conductivity is one type of conductance because K equal to G L by K. That means when area is taken as one unit meter square or centimeter square, L equal to 1 unit length centimeter or meter. At that time, the conductance of the material is becomes equal to the conductivity. That means G equal to A. Both become same. That means when we measure the conductance of material having a unit area and the unit length, then that is known as the conductivity. Siemens meter inverse is the SI unit. Sometimes it is also calculated in Siemens into centimeter inverse. This is not SI unit. SI unit is Siemens meter inverse. That means four basic terms: resistance, resistivity, conductance, and conductivity. Now, based on conductivity, substance can be classified into four categories. Based on conductivity, classification of the substance. Based on conductivity. Based on value of conductivity, substance can be classified into four categories. One, that is conductors. Second category is insulator. Third category is semiconductor. And finally, superconductors. Now, conductor means it having a very high value of conductivity. Conductivity value is very high. High value of conductivity, that means they are known as the conductor. Generally metal and their alloys. Example, metals and their alloys act as a conductor. Also remember, graphite is also the conductor of electricity. Certain organic polymers also act as a conductor. Carbon black also act as a conductor. Now, insulator, that means insulator having the very low value of conductivity. Very low value of conductivity. And the example of insulator, we know glass and ceramics. So many materials. Now, semiconductors. Semiconductor means it having the value of conductivity between the conductors and insulators. That means average range between the value of conductors and insulator. An example of semiconductors we know very well: silicon, again dope silicon, then gallium arsenide. So many examples. Now superconductor. Superconductor means what? Very high value of conductivity. That means very high compared to conductor. That means theoretically we can say it having a zero resistivity. Zero resistivity. Resistivity is zero. That means we can say resistivity zero. That means infinite conductivity. Infinite conductivity. These type of substances are known as superconductors. Now examples of superconductor. Certain metals and their alloys act as a superconductor at a very low temperature. That means 0 to 15 Kelvin. Metals and their alloys act as a superconductor, very low temperature, 0 to 15 Kelvin. Now certain materials are discovered that act as a slightly higher temperature compared to this one. That means certain ceramic materials and their oxide. That means ceramics materials and certain oxide act as a superconductor, slightly high temperature. That means up to 150 Kelvin. Up to 150 Kelvin. Now, why different material having a different conductivity? So obviously, the value of conductivity depends upon the nature of material. It will depend upon the nature of material and the structure of material. Different substance having different structure, so obviously value of conductivity will be different. So it depends upon the nature of material. Again, at which temperature and pressure the conductivity is measured. That means also depends upon pressure. It also depends upon the temperature. So keep in mind, value of conductivity depends upon nature of material, that means structure, pressure and temperature. Electrolytic conductance, that means conductance of electrolytic solutions. We completed the basic terms. Now electrical conductance take place in electrolytic solution as well as in metals. So they can be classified into two categories. First one is the metallic conductance, or it is also known as electronic conductance. That means the electrical conductance through metal is called metallic conductance. The electrical electrical conductance through metal is called metallic conductance. Why it is known as electronic conductance? So because we know very well in a metal, electricity is passed through by means of electron, and we know that is called free electron, otherwise mobile electron, otherwise delocalized electron. That means in metals, electrical conductance is passed through by means of electron. Therefore, it is known as electronic conductance. Now, on which factors electronic, otherwise metallic conductance depends? So, it depends upon first factor, nature and structure of metal. Nature and structure of metal. Different metal having a different structure, so different metal having obviously different value of metallic conductance. Second, numbers of valence electron per atom. Number of valence electron per atom changes. Different metal having different valence electron, so obviously metallic conductance will be different. And finally, third, it depends upon temperature. Remember, temperature increases, then metallic conductance decreases. Metallic conductance, it will be decreased. Again, when electricity is passed through metal, then we know very well electron enter from one end and then move towards the second end. There is no change in the composition of metal. Metal remains as it is. Only slightly temperature of the metal is increases. That means composition wise, structure wise, there is no change. To remember, when electrical conductance take place through metal, no change in composition take place. No change in composition of metal take place. So this is the first metallic conductance. Second category is electrolytic conductance. Electrolytic conductance, otherwise it is known as ionic conductance. Why it is known as ionic conductance? So obviously here conductance take place by means of ion. In case of metal, it takes place by means of electron. That means definition is similar to electrical conductance. The electrical conductance. Through electrolytic solution. That means electrolyte solution is called electrolytic conductance, otherwise it is also known as ionic conductance. Here conductance take place by means of ions, remember. Now, on which factors electrolytic conductance depends? So it depends upon first factor. First factor is types of electrolyte. Types of electrolyte. So we know very well electrolyte means the substance when dissolved in water it produces ions, otherwise it is decomposed by the current, electric current, that is known as electrolyte. Now electrolyte having the two types, strong electrolyte and weak electrolyte. Strong electrolyte means When it is dissolved in water, completely ionization take place. In case of a weak electrolyte, partially ionization take place. That means this type of electrolyte we are using on which depends upon electrolytic conductor. Conductance takes place by means of ion. That means more the numbers of ion in a solution, more will be the conductance. That means we have two types of electrolyte: strong electrolyte and weak electrolyte. In case of weak electrolyte, the ion numbers of ion in solution will be less. In case of strong electrolyte, more numbers of ions are there. So here conductivity is more. In case of when we are dissolving a strong electrolyte. Now second factor is the size. Size of ion and the solvation. Size of ion and the solvation factor. So remember size. Smaller the size will be the smaller, then what happens? Size will be the smaller, then more solvation take place. More solvation take place. And the more solvation take place, that means the conductance decreases. That means the size of ion decreases. Then solvation increases. That means we can say size decreases, solvation increases. Size decreases, solvation increases. That means ions are not free in a solution to conduct electricity. That means size decreases, solvation increases, conductance decreases. Remember, that means a smaller size ion having less conductance because due to the very high value of solvation. Second is the third factor is the nature of solvent. Nature of solvent. Nature of solvent, that means it is a polar and non-polar. Generally, electrolytes are more ionized in a polar solvent. That means higher the value of polarity of the solvent, conductance increases. That means in a polar solvent, conductance, value of conductance increases. That means more will be the conductance in a polar solvent. Fourth one is the viscosity of a solvent. So obviously, more the viscosity of solvent, ion having resistance to move for the conductance of electricity. That means obviously conductance decreases. That means viscosity increases. That means solvent having higher the value of viscosity than value of conductance decreases. Now fifth one is the concentration. Higher the value of concentration, that means concentration increases, and then conductance decreases. Why the concentration increases, conductance decreases? Because in case of a weak electrolyte, it having a less degree of ionization, that means less number of ions are there. In case of a strong electrolyte, at the higher concentration, interionic attraction and repulsion forces are more. That means conductance is less. But when the concentration is low, that means dilution is carried out. In case of a weak electrolyte, the degree of ionization increases. And in case of strong electrolyte, the interatomic attractive repulsive forces between the ion decreases, therefore conductance increases. In salt, higher the concentration, lower will be the conductance. Keep this point in mind, very very important point. Now 6 point is temperature. The temperature increases. Temperature increases, then conductance increases. Why temperature increases, then conductance increases? Because as the temperature increases, degree of ionization increases. That means more numbers of ions are produced in solution. That means obviously conductance will be increased. Remember this point in case of metallic conductors, temperature increases, metallic conductance decreases. Here temperature increases, then conductance increases. Keep this point in mind.